A curve passes through the point 1, 2.5 and has the derivative function f prime of x equals 6x squared plus 5x minus 1. Find the coordinates of the point on the curve where y equals f of x, where x equals 2. What a mouthful. So what this question is asking is it's given us the derivative, the gradient function, f prime of x, and it's asking us to find a particular point on the original function at x equals 2. So it's asking us for the coordinates of a point on the original function. However, we aren't given the original function, right, the curve. We are given the gradient function. So our first step is to find the original function, which is f of x, by anti-differentiating f prime of x. Right, so the antiderivative of f prime of x will give us f of x, which we need to find the coordinates of the point on that function. So we are given f prime of x as 6x squared plus 5x minus 1, and we are anti-differentiating to get f of x. So the antiderivative of 6x squared is 6x to the power of 3. So we added 1 to the power, so 2 plus 1 gives 3, and we divide by the new power. Right, so the new power is 3, so we divide by 3. And the reason why we do this is because if you recall, to differentiate, we'd take the power multiplied out the front, so the 3's would cancel, and then we subtract 1 from the power, which gives us 6x squared. Right, so the antiderivative goes the other way to the derivative. So you can always check your answer by differentiating. Alright, the next term, plus 5x, becomes plus 5x squared, right, we added 1 to the power and divided by the new power, 2. The antiderivative of minus 1 is minus 1x. Right, and where does that come from? Well, we can think of it as initially minus 1x to the power of 0, because that's just equal to 1. We add 1 to the power, and we divide by that new power. Right, and so we're left with minus x. Just simplifying the first term, 6 divided by 3 gives 2. And 5 over 2 stays as is, and so does minus x. Alright, have we anti-differentiated? Not quite, right? Remember, whenever we anti-differentiate, we have this unknown constant plus c, and that's because the derivative of a constant is 0, but the antiderivative of 0 could be any constant. Okay, so we almost have f of x. Now how do we find what that constant is? Well, we need to know a point on the original function. And we are given an x point and a y point, right, or an f of x. So we can substitute in that point and solve for c. So doing that, in for f of x goes 2.5, in for x goes 1. Using brackets when we substitute, just to be careful of any powers. And now we see we have one equation, and the only unknown is c, so we can solve for it. Let's see what we get. I'm hoping someone puts a laughing sound effect there. Okay, I'll do it myself. 1 cubed times 2 is 2. 1 squared times 5 halves is 5 halves, or 2.5. Minus 1 plus c. So that's 2.5. We'll subtract 2.5. So 0 equals 2 minus 1, so that's 1. So c would equal negative 1. Alright, so putting that run out of room already. Putting that together, we have, let's go over here. We have f of x, well, we worked it out, except we just found out c. So 2x cubed plus 5 over 2x squared minus x minus 1. Oh, run out of room. There we go. Minus x minus 1. So that's the original function. Now, the question is asking us to find the coordinates of the point where x equals 2 on the original function. So our last step is to substitute in x equals 2 into our original function to find the y value, so we can then state the point. So f of 2 equals 2 times 2 cubed plus 5 over 2 times 2 squared minus 2 minus 1. 2 cubed is 8, 8 times 2 is 16, 2 squared is 4, which is 20 over 2, which is 10, minus 2 minus 1. What's that? 26, 24, 23. Therefore, the point is at x equals 2, which was given, and then y equals 23. So just to quickly recap that question, we were given the gradient function, the derivative, f prime of x, and we were looking for a point on the original function. So we first recognize we have to find the original function by anti-differentiating. Right, so we did that, and if we got up to f of x without the constant, so plus c, that is the achieved component. We then realized we had to solve for c, right, by substituting in the given point on the function, so that we could then put it back into our function and solve for the y value. And in solving for the y value, we then found the point, right, the x comma y point. And we're done.